Hi, this is Alex from devstories.eu. NVIDIA NeMo Guardrails, Episode 2 of 10. Writing raw Python to manage complex, branching dialog state machines is an absolute nightmare. The moment your user deviates from a rigid script, your hard-coded logic breaks. The configuration architecture in NeMo Guardrails fixes this by treating conversations as event-driven flows instead of static code. NeMo Guardrails separates the mechanics of your application from the logic of your conversation. This happens across two distinct configuration pieces. First, you have your YAML configuration file. This handles all the model wiring. It is where you declare your main language model, define your embedding models, and register custom application actions. The YAML file connects the underlying infrastructure. It provides the engine, but it knows absolutely nothing about what the user will actually say. The actual conversation logic is governed by Colang 2.0. Colang is an event-driven interaction modeling language. Instead of writing standard imperative code with endless conditional statements to track where the user is in a conversation, you define flows. A flow models a sequence of interactions. When a user sends a message, it generates an event. The state machine catches this event, looks for an active flow that matches the interaction, and dictates the assistant's next move. This is the part that matters. Colang uses natural language descriptions to bridge the gap between strict code and human ambiguity. Instead of writing complex regular expressions to parse a user message, you instruct the system using human language right inside your flow logic. You pair these descriptions with the generation operator, which is written simply as 3 dots. When the state machine encounters those 3 dots, it temporarily pauses execution. It hands the current context in your natural language description over to the underlying language model, asking it to generate or extract the exact value you need. Let us look at a concrete scenario like booking a flight ticket. You need to know when the user wants to travel. In your Colang file, you define a flight booking flow. Inside that flow, you tell the system to wait for the user to speak. Once they do, you need to extract the date. You declare a context variable, perhaps called flight date. You assign it the value of a natural language description, literally writing out the phrase, the date the user wants to fly, immediately followed by the generation operator, those 3 dots. When the user says, I need a ticket for next Tuesday, the Colang state machine captures the event. It hits your variable assignment. It passes the user message and your natural language instruction to the language model. The model reads the context, identifies next Tuesday as the target value, and returns it. The generation operator resolves, and your context variable now securely holds the extracted date. Your flow then proceeds to the next step, which might involve calling an external booking API to find over in your YAML configuration. The real power of this architecture is that you stop fighting dialog states with rigid code. You let a YAML file lock down the static infrastructure, and you let Colang use the reasoning capacity of the language model to navigate the unpredictable reality of human conversation. I would like to take a moment to thank you for listening. It helps us a lot. Have a great one.